Well, for one thing, it helps me get work because my clients, they need help with Akka, and then they come to me, and that's how I get work to do. So that's already a big help. But the other thing is that Akka is really good, but it was designed actually to be to help building distributed systems. And now distributed systems are hard. They can be quite of a headache. And what Akka does is it does all the groundwork for that. So there's really only two reasons why you should be using building a distributed system, or you shouldn't just stay on one node. The first reason is that you have so many things to do, so many resources to use, CPU, network, storage, bandwidth, whatever, that you can't fit it all on one machine. You can't scale up vertically anymore. So that's the one reason. The second reason is that you could run it all on one machine, but then if that machine crashed, your application would be not available anymore. And so you want this resilient failover, you want this automatic failover. And Akka provides all of these primitives where it takes care of doing all of this automatic failover. All of these primitives such as cluster singleton, cluster sharding, distributed data, all of these things, all of these components that Akka provides are there and allow you to build an application that's really resilient and without having to build everything from the ground up. And what's really good is in its approach, Akka doesn't lie and doesn't try to hide the complexity behind it. It just says, hey, these are the guarantees we can give you, and you have to be careful and take this into consideration. And not that many technologies out there go to that length and try to be that explicit about all of the realities of the environment. If you look at the charter of the Cloud Native Computing Foundation, it says that it's there to help organizations build and run scalable applications in a highly dynamic environment, clouds, private clouds, service meshes, etc. And this highly dynamic and scalable aspect is something that Akka has covered from the start. It's designed to be built as a cluster. Akka is actually designed to be running as a cluster, and it runs locally. It's just an optimization, the fact that it runs locally, but its sort of ground home environment where it's really like a fish in the water is the distributed aspect of it. And if you look at most technologies out there, they will be stateless technologies. You know, Kubernetes, when it started, it was all about containers, all of these things, but all stateless. And I mean, stateless is nice, but it's not all of that. You know, there is a large portion of problems that require state and fast state that's there in memory, not somewhere in a database where you don't have time to go to the database. You don't need to have it around in memory. And Akka does have that. And it can run in these dynamic environments where nodes come in and come out, where the Kubernetes pods are reallocated, etc. Akka can deal with all of that. So I would say that makes Akka a very good match, and it makes it quite unique because the fewest frameworks out there have really started to think about all of this in-memory state management problem. Akka is just, I would say, in the forefront of that.